Hey guys, this is Tim from Tim's Electronics Lab and welcome back to another revisit of one of my projects, the solar powered ESP8266. Now, the thing has been running for a while and recently the weather was very good, lots of sun, but I noticed that the solar panel was not able to charge it whilst the ESP was running during the previous months. So I removed the ESP from the PCB, and yeah, that's the whole point, to have an ESP. So it hasn't been active, but let me check the voltage right now. Probably good. Come on, where are you at? So it's at 4 volts right now, and before the sunny days started, I think it was around 3 volts, so it has charged, but again with the ESP removed, and that's no good. Let me adjust the focus again. I'm getting really tired of this thing. So what we're going to do is we're going to cut these cables and connect them to some kind of terminal, and then we're able to measure the amps that or the milliamps that the solar power delivers to the charging chip, because I've got the bottom belly feeling that this LED that's on here, the red LED, that is drawing the amount of current that the solar panel delivers. So the total charging current is basically zero, because only with lots of sun this thing will charge, and the red LED is practically always on. So if I desolder it, maybe the thing charges better. So let's see. First let's disconnect the PCB. Now there's nothing on it, but it makes the thing a little more convenient to do. So I've got a pair of these terminal blocks and my trusty old cutters. Now I'm thinking as well to extend these wires, so let's just do that anyway. Now I won't need this for a while. Let me see where I can put it without shorting it, because that's a nice thing. Yeah, let me grab some wires. So I managed to find about the same color. Turn on my soldering iron, because we will need that. So now I've got with the extended wires, I've got a lot more flexibility on where I put the solar panel, because right now it's very limited to yeah, a few centimeters outside of my window, and that is not always the most optimal spot for the sun. Alright, let me grab a few, actually 2 heat shrinks, colored heat shrinks. Yeah, I did an upgrade. Alright, now soldering iron is up to temperature, and I found this really nice wire holder on Thingiverse. If I remember, I'll link it down below in the description. And this makes soldering wires very easy, if you use it correctly, of course, but that's with everything. So like that. Our big solder. pretty thin. Alright, cool. I think that's very good. Nice and strong joint. I really like this helping hand kind of thing for wires. It's really good. But you need to be careful though with your soldering iron, because it's still 3D printed plastic and your soldering iron is able to melt it with ease. So yeah, that's a danger of using this thing. Alright, cool. That's also very nice. Nice. So those are soldered now. Now I need to connect this to this. And if I connect this one to this one, the LED should, yeah, there you go. So it's working. I need to disconnect these and put it in here, and the other one put it in here. I'm breaking down the plate. Now I'm curious what happens if I put it into current measuring mode. Oh. Come on. Backlight on, please. There you go. And so now it's charging. Ooh. It's charging through the light of the workbench light. So not a huge amount of energy produced here. So let me take it outside and see what the measurement is over there. So as you're able to see, 11 milliamps of current is produced by the solar panel, and the weather is not optimal at all. And basically I think it's all used by that LED. So the batteries are not charging. Let's drop them too. I just put my hand over it and it basically dropped down. So I'm going to desolder or disconnect this LED and check if yeah, I can't compare it with this, because this is the current from the solar panel that's out of the window. So I need to compare it with the battery charge stats that I roughly noted inside my head. So we're back at the workbench. Let me disconnect this, because it's nice. This out of the way. And we need to desolder this light, I think. Wait, which one? We need to desolder the red one, but I can't remember what the red one was. So let me just look it up quickly. Come on, solar panel, you can do it. You can charge. I've got the faith. Alright, so this is the LED we need to remove, this one. And I'm going to need some desoldering wire for that. Well, I think I will need it. Ooh. I just ripped apart the LED. Well, the glass part of the LED. There you go. So that's desoldered now. And plug in the charger. Yeah, 4 volts. So that's good. That's working as expected. I think. I'm hoping. So let's desolder these wires and transplant them over to the other board. Nice. I'm going to immediately connect the positive battery wire into a terminal block, because if it shorts with the negative wire of the battery, yeah, you know, there are 5 18650s connected in parallel. So I'm not sure if that's going to end very well, since that's a lot of power and they're almost topped off. We now should have a voltage if I probe these two, and that's good. 4 volts. Yeah, minus because I flipped the positive and negative leads around, but that doesn't matter. Very nice, very nice. So it's outside, and as you can see, it's drawing more current. I'm not sure if that has something to do with the LED, but 16 milliamps. That's good. That's really good. You know, no LED. That's fine. I think we should give the ESP a test. It's still increasing. Let me see what the upper limit is. So I think it's topping out at 17.6 milliamps, maybe 18 at max. So let's connect the ESP and check how much current that uses. Alright, ESP is booting. 70 milliamps. So now sleep. Oh, this is good. 3 milliamps sleep. This is good because the thing charges at 17 milliamps. So the charge rate is higher than the sleep rate. Or the charge current is higher than the sleep consumption current. And that's very nice, because it means we should be able to charge the thing when it's in sleep. And that LED, I'm not sure what kind of LED it is, but I think it draws around 20 milliamps, maybe 10 max, and that was basically the charge current we just had from the solar panel. It was less than 20. So if you do your calculations, you'll end up with, I think, 4 or 5 milliamps of total usable charge current, and that's way too less. No, this is good, and I think it waits for 10 minutes before it goes out of sleep and sends the data. So we've got 10 minutes of a charging window of 10 minutes, and then it consumes quite some power, I think, and then it charges again. So I'm going to put this outside of my window with the ESP inside it, and I'm going to keep track of the voltage on the batteries. So I'll keep you updated on that. So thanks for watching this video. I hope you found it interesting, and as I said, there will be a follow-up video again, because this is a project that is not ending very soon, I think. That's good. And I'll speak to you and see you in the next video. Bye! Thanks for watching this video. I hope you've enjoyed it. If you did, please leave a like. Make sure to leave a comment down below. You can also share this video with your friends if you think they will like it too. See you next time.